Hello everybody and welcome back to another episode of Whiteboard Wednesdays with Vanna and Richard. Richard is back, he's joining us. We've had a very subjective poll, as I've mentioned before, and we believe that it is in your best interest that Richard joins us on this show. So Richard, welcome once again. We always enjoy having a chat together and just talking about technology, artificial intelligence, GPUs, and other areas within the realm of data and data science and that type of thing. So what we're talking about today is a bit of plumbing.
Yeah.
Every good house, every good car, every thing that basically works well, even a human, has got to have exceptionally good plumbing, right? So the same thing when it comes to building a supercomputer or effectively, moving data across from where the data is stored to the GPU itself, right? So we know that the GPUs of today are absolutely powerful, and those that power can be extrapolated when you start interconnecting those GPUs, right? And also the storage and the amount of data that we have to train large language models and thing is insane amount of data. The trick is how do we do that at a rate that makes sense and doesn't take us 500 years to do something clever. So NVIDIA is solving that. Apparently,
I believe so.
From what we've seen in their latest release, they've released a new switching architecture for Ethernet switching, and they're calling it Spectrum X. So they've got Spectrum, a whole bunch of different Spectrum things, but this is Spectrum X. What is, Richard, Spectrum X?
Well, Spectrum X is effectively exactly what we're discussing here. It's the plumbing of your, well, let's put it this way.
It's the network.
It's the network, but it's the plumbing of tomorrow. It's the supercomputing plumbing. It's the AI plumbing. It's how do we get the amount of data, not just that currently exists, but that will exist. We all know the weird and wonderful sort of numbers that people throw out about how data is growing exponentially from one day to the next. So that's all good and fine, but if we have the most incredible graphics cards and we can store all the data on the fastest storage, if we can't get it there at any reasonable rate, well then what's the point of the storage and the graphics cards being as good and or powerful as they are? And in fact, we were just discussing earlier what would be hopefully a viable metaphor for the sort of the challenge that we're trying to overcome with Spectrum X, and that is what you could consider is if you have a car with a big powerful V8 engine, and then you have a petrol tank that you will obviously then use to feed this engine,
but like a really clever one, like a
high performance something or other with
F1
huge
car,
pumps, like an F1 engine,
F1 optimized, proper.
Absolute.
Not a Model T Ford.
Not a Model T Ford, but like the top of the pops.
Yes.
Because this engine needs to take in that petrol as fast as it can. Because if you don't get in a petrol, your engine doesn't turn over as fast as it should.
Yes.
And then you try to push all that petrol across through a straw.
Not going to really.
What's the point? Then you're not going to get the benefit out of the engine or this fancy petrol tank. So how do we then upgrade that straw to be properly more than sufficient? To drive,
not to be the bottleneck.
That's what we're trying to get away from. And NVIDIA has obviously, from one of the companies that they brought on board a few years ago, Mellanox. Between the two of them, they have come up with Spectrum X, which just throws out the most unbelievable numbers in terms of how much data it's able to send and receive and transmit between all the various systems. And taking that one step further, of course, NVIDIA being the AI GPU technology people, tightly coupled and integrated the AI GPU technologies with this, what becomes this fabric of data, to the various storage endpoints to create the most incredible pipeline to get your data where it needs to go, to be processing it as fast as is
possible at the moment.
That fast it's actually physically possible at the moment. And getting all that information and extrapolating all that data. And of course, the more data we have, the more accurate we can be.
Absolutely. So, let's we don't always delve into speeds and feeds, but when we do it properly. So, these new switches, the 5000 series switches that they're bringing out, we're talking 800 gigabits per port.
800 gigabits per port. That's as if there was a company of 800 staff members all sending all of their information over their various laptops. If they were 1 gigabyte laptops,
so a typical modern
Mac,
laptop, Windows or
whatever machine that they're using, and they're all sending their information all at the same time. And you could do 800 people into one
of those ports. And these switches are coming at like 32 ports, 64 ports.
Exactly.
And what's happening is that those ports are interconnecting, almost direct connecting the GPUs that are within a system with the other GPUs that are in another system. Right now, if we think about NVIDIA's DGX platform, the actual switch that interconnects the GPUs in that machine, that bus is about 900 gigabits a second, right, which is faster than PCI 4 with this way. And now the external switching, which has always been kind of the bottleneck, right, is almost on par with that internal bus.
That bus, which is effectively on a board,
yeah,
just chips communicating to one another, and we're now saying that we have a switch that can connect things at near the same performance across systems.
Yeah. Those buses, those board buses, effectively with other ones, right? So those NV switches, that's what they call. They're the NV switch technology. Are now interconnected at nearly the same speed as the actual NV switch. So this is really, large language models. The next frontier has always been that kind of trillion parameter models, right? This is what will push us into, fully harnessing those type of models.
Yes.
This is what will drive the amount of data that 5G networks are capable of doing, and bringing that back into your data center, and pushing the boundaries of GPU accelerated data center platforms and harnessing that through this new Ethernet kind of technology. And am I correct that they are also integrating this tightly with Bluefields 3, the DPU technology?
Yes, I believe so. Yeah.
So bringing those elements tightly together effectively, just turns that DPU computer network interface into a super fast access point directly to the data storage media that's there. So what's really happening is there's such a stripping away of superfluous elements, in which the data is to travel, and really just streamlining that entire process, that entire pipeline at a plumbing level, right?
Yes, absolutely.
So what we're talking about here is not at an application level. It's not at your this is all within the actual computer components, the actual physical platforms that have to interconnect, that allows the sexy data science applications and for ChatGTP to operate, right? When you get that feedback and it types out that screen, it is literally running across a network like this in the background, and that's how it's getting that data so quickly.
Yeah.
So these switches are now been released to the general market, enterprise market. Data Sciences Corporation, being a NVIDIA partner, can provide these solutions. Our latest platforms, we can start building, utilizing the Spectrum X infrastructure. So if you're a forward-thinking organization looking at employing things like generative AI, rendering into your organization's workflows, and revolutionizing the industry and your organization, and creating new, unique opportunities and value points, please look at this type of technology and reach out to us if you want to discuss how you can benefit from that. So thank you so much once again for joining us as the audience, and Richard, our general purpose expert across technologies. Really great to have you on the show again. And we'll see you guys all next time. Thank you very much.
Cheers.
In order to build new AI clouds, a separate AI fabric is necessary. AI workloads are unique and generate large network flows that lead to increased impact on the network. Running these workloads on existing cloud infrastructure built on traditional Ethernet introduces significant congestion, increased latency, and bandwidth unfairness. This causes performance loss and the inability to effectively utilize the system's GPUs. The NVIDIA Spectrum X networking platform is the world's first Ethernet fabric built specifically for AI workloads, delivering AI cluster performance up to double that of traditional Ethernet. This end-to-end NVIDIA solution starts with the Spectrum 4 switch featuring the impressive Spectrum 4 ASIC. Powered by NVIDIA innovation, this ASIC provides numerous groundbreaking features that puts it in a class by itself. The Spectrum 4 switch works in tight coordination with the Bluefield 3 DPU to ensure optimal resource utilization and efficient data transfer within AI clusters. It comes with enhanced RoCE features such as adaptive routing, performance isolation, and congestion control, all combined in an optimized full-stack solution. The Spectrum X networking platform delivers acceleration technologies over standard Ethernet protocol, achieving the highest effective bandwidth and delivering low jitter and short tail to maximize AI performance. In this real-world example, Spectrum X delivers 1.7 times higher performance in terms of performance per GPU, power efficiency, training time, and total cost of ownership. Additionally, AI models utilizing nickel all-reduce achieve 2.5 times higher effective bandwidth, enabling faster and more predictable training. Continuous optimizations across the software stack, libraries, and operating systems ensure optimal performance and interoperability of the AI infrastructure. The NVIDIA Spectrum X networking platform, powered by Spectrum 4 and Bluefield 3, accelerates performance and time to market as the first purpose-built Ethernet fabric for AI.
Please don't forget to like, share, and follow our LinkedIn page.